This video is part of the complete front-end development series that I'm currently working on. If you are interested in becoming a front-end developer, I will post a link to the playlist down in the description so that you can start your front-end development journey. But in this video, we are specifically going to focus on different kinds of tests, and we will also be talking about some common misconception, mainly about unit tests and test doubles that exist even in an enterprise developer. So as you can see on the screen here, this is a test pyramid. You must have already seen this pyramid everywhere out on the internet, but this is the test pyramid, and you can see that there are three kinds of tests. There is unit test, there is integration test, and there is end-to-end test. And you can clearly see in this testing pyramid that this unit test is in bold. It's big, and it also occupies biggest space here in the pyramid. Okay, and if you look at integration test, it occupies less space as compared to unit test, but again, but still, integration test, it occupies more space than end-to-end test. And if you look at end-to-end test, it is right at the top, right at the summit there, and it has a less space. So what this is implying is for the unit test to be in the bottom here, occupying more space, what this is telling is we write a lot of unit test. Okay, and we will come to a reasoning behind this in just a bit. But if you look at integration test, it's the space is a little bit bigger than unit test, but still we write a lot of integration tests, but we write fewer integration tests than unit tests, but still we write more integration tests than end-to-end tests. And when it comes to end-to-end tests, the space is super small there, implying that we write a less end-to-end test. And the reasoning behind this is that end-to-end tests cost less money, they require less powerful servers, and when we are talking about complexity of the test, unit tests are super easy to write. And when we are talking about speed, unit tests run super fast. Okay, so that's why people focus, or developers focus, on writing a lot of unit tests. And when it comes to integration tests are just a little bit complex than unit tests. Integration tests require a more powerful server as compared to unit tests. Integration tests are a little expensive than unit tests. And when it comes to speed of test, integration tests run a little slower than unit tests. When we are talking about end-to-end tests are the most expensive tests to write. End-to-end tests require powerful servers. End-to-end tests take forever to complete. Okay, so that's why this you see this testing pyramid. It is implying that I write a lot of unit tests, write a few integration tests, and write very few end-to-end tests. Okay, and let's talk about what each of these tests mean, because I have a complete opposite diagram that you will see in the screen on top here very soon, and I will explain my reasoning to why I did this. But this is the common pyramid that you see. So let's talk about different kinds of tests first, what they do and where they are used. So let's talk about unit tests first. So whenever somebody says they are unit testing something, it means that they are unit testing a single functionality, a tiny piece of code. They are unit testing that. Okay, and whenever we talk about integration tests, it means that we are integrating maybe one function one function with another, and then we are writing an integration test. But when we are talking about end-to-end test, we are testing entire system as a whole. Okay, so for example, let's come to this unit test. What I mean by this testing single piece of code is I have this very simple function here that all it does is it validates password, and this validate password function is used in UI. So to give you an example, I have a web page open here. So this create password field, in order to unit test this validate password function that is used within this create password field, in order to unit test this, these are all the tests we need to write. So there are 1 2 3 4 5 test cases that we need to write, because password is validated if the password is between 8 and 32 characters. Password is valid if it contains at least one digit. Password is valid if it has at least one uppercase letter. Password is valid if it has at least one lowercase letter and at least one special character. So in order to unit test this create new password field, especially the validate password function, we will need to test each of these 5 functionalities in isolation. So let's go and look at the code. So this is the validate password function. It takes a password. We can also supply min length and max length when using this validate password in UI component, like in this create new password field. And then we use some regular expression in order to validate the password. We format the password, we check if the password is empty, and then we return true if the password is valid. We return false if the password is not valid. In order to unit test this function, let's come down to this test suite here called validatepassword.test.ts. We describe a test suite called validated password, and inside that test suite we write test cases for each of the functionality, for each of those 5 functionality. So the first thing we do is we describe the test case called test suite called validated password, and we write the first each block, okay, saying should return false for password less than specified min length, and then we call that validated password function. We provide a password, because remember this validated password function takes 3 arguments: password, min length, and max length. So we supply the password. In this case I supplied AD1 and special character dollar. The min length should be 8, the max length should be 256. But in this test case we are only checking for min length, okay. So in this case, when I call this validated password function, I supply that password, I specify the min length to be 8, and it is going to return false because this password is not 8 characters, is not at least 8 characters long, okay. So this is one test case. The other test case we can test for this validated password function is that we can check for a max length, and here again we supply the password, we specify the max length to be 10, but since max length is 10, I don't know why somebody would do that, but just for example, let's suppose that the password max length is 10, and you can clearly see that the password provided here is more than 10 characters, so that's why we return false in this test case. And in other test case we check for uppercase letter. We call that validated password function. We supply the password. Since this password does not have any uppercase letter, we return false. We expect, or not return, we expect the function to return false, okay. Same with lowercase letters. This password does not contain any lowercase letter, that's why we expect it to be false. And we also unit test of digits. So if the password contains at least 1 digit, if this password does not contain any digit, so that's why we expect it to return false. And same with special characters. This is the password provided, does not have any special character, that's why we expect it to return false. And we can write other test cases for the result for the case that returns true. But just for example, these are all the test cases, unit tests that we write for in order to unit test this validated password function, okay. So we will come back to this in a little bit, but for now let's go back to this diagram here. So that was about unit tests. So we write a lot of unit tests. You can see that this test suite gets so long. There are probably more than, in order to unit test this create new password field or the validated password function, there are so many test cases that we can write, and this will probably be about 50 test cases or even more test cases just to unit test this validated password function, okay. So now let's go back to integration test. So integration test, when we are writing integration test, we are testing to see if one component integrates well with another or not, okay. So that's why we write unit test. And to give you an example of unit test, again, let's go back over here. So I have this create new password field, okay. This is a React component that utilizes text field. So when we are writing integration test, we are trying to test, does this create new password field integrate well with the validated password function, okay. So that's what we are trying to test whenever we are writing integration test. Does this create new password field, this UI field, this text field, does it integrate well with the validated password function, okay. So that's what we do when we write integration test. And for end-to-end test, we are trying to test the entire system, okay. In this case we are trying to test entire application, entire website. You see now, right now this is a static website, doesn't do much, but when it comes to end-to-end testing, we are basically trying to test this entire application, entire system as a whole, okay. So with end-to-end tests, what we can do is we can use a automated testing software like Cypress, Selenium, Puppeteer, whatever tool you want to use. But when it comes to end-to-end testing, let's say for example, we can tell Cypress, that is a testing software, we can tell Cypress, hey Cypress, go and using sci.visit, and once you are in the URL, so this is the site for the core package that we are developing in that front-end development series. Again, if you are interested, look for the link down in the description if you are interested in becoming a front-end developer. But anyways, we will tell Cypress to go visit this URL here, core, and then once you are in that page, click on this getting started button. And remember, Cypress, once you click on that getting started button, you should arrive at a page called core API typography. Make sure that you are in that page. If you are not in the page, give me an error and I will go fix it. Okay, so that's the kind of thing that we are testing when it comes to writing end-to-end tests. And again, we can tell Cypress, hey, Cypress does this because you see a breadcrumb on top here. So it is displaying the breadcrumb core API typography, and this is a breadcrumb component that we will write. Okay, but for now, this breadcrumb component is using this URL in order to get the path name. Okay, so again, we can tell Cypress, hey Cypress, once you are in core API typography page, can you look at the breadcrumb and make sure that the URL matches the breadcrumb, and if it does, its test is successful. And we can also tell Cypress, hey Cypress, once you are in core API typography page, can you click on the core link? So that's the core link, and once you click on the core link, you should arrive at the core page. Okay, so and there can be, let's say that if there are 100 pages, 200 pages in a site, when we are when we are writing end-to-end tests, we are testing the entire system as a whole. So that's why you can tell how powerful server the end-to-end test needs. And also it takes a lot of time because the testing software have to individually go to each of the pages. It has to click all the buttons, and it has to test everything as a whole, everything combined. So that's why integration tests are expensive. They require a lot of time to run, and they also require large servers to run. Okay, so that's the concept of end-to-end tests. So let's come back to this pyramid here. I hope you understood unit tests, integration tests, and end-to-end tests. This is the most common pyramid that you see, but I did something different to this pyramid, as I showed you earlier. If I scroll to the top, you see that I flipped this pyramid basically upside down. Okay, if you look over here, the unit test is at the bottom, integration test is in the middle, end-to-end test is at the top, but I flipped it and I put end-to-end test at the bottom. That occupies the largest space, and then there's integration test still in the bottom, but this unit test is at the top occupies less space. And you see that there are some test doubles that we will talk about in just a little bit, but why I did this is, and some people might disagree with me on this, as to why I flipped this upside down. So this when I flip this upside down, it basically means that I'm trying to imply we write a lot of end-to-end test. Okay, we focus more on end-to-end tests. It has more space in this pyramid. And then for integration test, just like with the pyramid down below, integration test, we write fewer integration tests than end-to-end tests, but still we write a lot of integration tests than unit tests. And for unit test, I am basically implying that we write fewer unit tests, fewer than integration tests and end-to-end tests, but still we write a lot of unit tests. Okay, and the reasoning behind this is why I flipped this upside down, just to understand this a little better. Let's try to again recap what each of this test is. So whenever we are unit testing, we are testing a part of a piece of code in complete isolation, like you saw in this validate password function. We are testing each of these functionality in complete isolation. We are writing the test case in order to test for a single behavior. Okay, so that's for unit tests. And for integration tests, we check if the validate password function here integrates well with the UI create new password field component. Okay, let me go back here in this create new password field component. And for end-to-end test, as I stated, we test the entire system as a whole. So again, we can tell Cypress, hey Cypress, once you are in this core page, go and type in some password here and test if this password field is working correctly or not. So and let's now come to the reasoning as to why I flipped this, because you can see that when we write end-to-end test, we are testing everything. So whenever we do end-to-end tests, and you will see this being applied in practice when we start writing unit tests, integration tests, and end-to-end tests for the component library that we are building in that front-end development series, and also the documentation websites we are going to build using Next.js. Okay, but whenever we are writing end-to-end tests, we are testing entire system as a whole. This, and the most important thing is, this is the closest end-to-end test is the closest we can get to a human interaction. Okay, so we are testing the software, we are testing the application from the perspective of a human that is going to use our component, that is going to use our app. Okay, so that's why I like to focus so much on end-to-end tests and not worry as much about unit tests and integration tests, but I still like to write unit tests and integration tests and test each of the component, each of the functionality in isolation. I like to focus more on end-to-end tests because this is the closest I can get to a human interaction. Okay, whenever I am writing end-to-end test for the entire app, I am already testing things that the unit test does. I am already testing things that the integration test does. Okay, and that's why end-to-end test. That's why I like to focus more on end-to-end tests, because whenever we write end-to-end tests, we are testing whatever the unit test, we are already testing that. We are testing the behavior. Integration test, whenever we write end-to-end test, we are already testing. We are also testing whether something's integrated or not. And whenever we write end-to-end tests, we are also testing whether something works in complete isolation or not. So that's why I like to focus so much on end-to-end tests, and throughout the front-end development series we will focus a lot on end-to-end tests. And yes, there are also component testing in Cypress that we will be writing. And you might be wondering, well, there are so many different kinds of tests, where do other types of tests fit? So let's say that, for example, where do component test fit in this pyramid? So from my understanding, from my perspective, I think component test fits in all three of these, because if we think about component testing, we are testing a single component in complete isolation. So that can also imply that, well, it's basically just like unit test then. And so maybe it is. But when it comes to integration tests, well, is component testing similar to integration tests? Well, maybe it is, because let's say that if we are testing this create password field component, this create password, as soon as I click on this create new password field, this div or a box shows up with all these errors. So whenever we write component test in order to test this create new password field, we are also trying to test, does this integrate well with this div? Does the create new password field show the div whenever I click on this, and does it hide the div whenever I don't focus on that text field? So maybe component testing is also like integration test, and also component testing can also be thought of as end-to-end test, because we are testing the component, in this case the create new password. We are testing how it integrates, and we are testing the create new password field from one end to the another. So we can, when we are writing integration end-to-end tests, we can tell Cypress to maybe type something and then give us the result, whether we can expect whether the test to fail or test to pass. Okay, so that's why I flip this. If you have different opinion, if you have different understanding on this, as to if you have any problem with me flipping this upside down, let me know down in the comments below. I really love to hear people's opinion on different kinds of things, their experience on different kinds of things. But that's why we did that, just to imply, I flipped this just to imply that we need to focus on writing more end-to-end tests, especially in production environment. Okay, because when we are unit testing something, we are only testing that particular functionality in complete isolation, and we do not know what happens when that function or when that service is integrated with another function or another service. So that's the problem with writing unit tests. Just because they are super easy to write, super simple to write, it does not mean that unit tests provides I would like to call it like a satisfaction. Well, whenever you write unit tests, you know that the piece of code works great in complete isolation, but what happens when that piece of code is integrated with something else? And unit testing does not do that. Same with integration test. It tests the integration, but it does not test the entire system as a whole. And when it comes to end-to-end test, this is the thing that I like to focus on. I like to test the entire system, and I like to test if everything is working correctly or not. Okay, but throughout that complete front-end development series that we are working on, we will write all these kinds of tests. And when it comes to documentation side, we will mainly focus on end-to-end tests and write very few unit tests there and focus more on end-to-end tests. Okay, so that was about end-to-end tests and integration tests and unit tests. So now let's start talking about these test doubles that you see here. So when it comes to unit testing, there is this big misconception about especially about test doubles that exist even in an enterprise developer. So whenever they want to unit test something that is so let's say that they have a function, they have an impure function that has additional dependency or side effects, and whenever somebody wants to unit test that function, then they want to mock that side effect or dependency within that function. And I ask people, well, what do you mean by mock that dependency or side effects? Because this mock, this mock that you see, it has been an umbrella term in order to describe all these other test doubles like dummy, stub, and fake. So now that's what we are going to focus on, and why that misconception exists, and also the differences between each of these test doubles or each of these tools. Okay, so let's go back to the code and try to understand each of these test doubles. Okay, so let's look at this validate password function. Okay, so let's talk about dummies first, because we'll talk about dummy, stub, fake, and then in the end we'll talk about mock. Okay, because these are completely different tools that a lot of people misunderstand it, but let's look at this validate password function. So this validate password function takes a password. Okay, this is required. It takes min length and max length also, but this min length and max length can be optional. Can the password be at least, maybe let's say 1 character? Of course it can, but that is not secure. But yeah, we can have the password to be 1 character, and maybe for max length the minimum character can be 1, maybe the max length can be 1 million characters. We can allow that, but is that practical? No, but still we can do that. So when we look at this validate password function, the only thing that is absolutely required here is the password itself, okay, from the user. The min length and max length property does not have to be required. Okay, it does not need to be required. So whenever we are talking about dummies, okay, so whenever we write a test for this validate password function, whenever we write a unit test, in this case we can use a dummy. Okay, so dummy is, the simple definition to dummy is, so dummy can be an object or a value that you need to pass to a function as a parameter, or you need to call that function, or you need to pass that value as a parameter to a function just to satisfy the parameter list. Okay, so in this case, if we look at this validate password function, it takes the password that is absolutely required, but it also takes the min length and max length. So whenever we are writing unit tests in order to test this validate password function, so let's say for example, whenever we are writing unit tests in order to test for a password uppercase, we do not need this min length and max length whenever we are testing for uppercase letters, whether the password contain uppercase letters. Okay, but do we still need to supply this value, the min length and max length value, whenever we are testing for uppercase letter? Yes, of course, because we are calling this validate password function, we are providing the password, and if we do not provide the min length and max length, it is going to throw an error, because validate password requires 3 arguments, okay, because it takes 3 parameters. So that's why we need to pass this min length and max length whenever we are unit testing this validate password function. So this is where we use dummy, okay, because we are passing this 8 and 56. Does it do anything in this test? Does it impact this test? No, this min length and max length property, or this value, does not impact our test. We are only satisfying the parameter by passing in these 2 values. So that's why we are using dummy here. That's why we say that we want to use dummy, passing that min length and max length. And whenever we are testing whenever we are writing unit tests to check for uppercase, we pass in this dummy. It does not do anything. This min length and max length doesn't do anything here. Okay, so that's the concept about dummy. So now let's, and also dummy can be a function, right? In this case, a function that returns an object whenever we are testing it, but in this case it is just a value that is not used in whenever we are writing unit tests for this, to check for this uppercase letter. Okay, so now let's talk about stub. So before talking about stub, before going into greater detail, let's try to understand what stub is. Okay, because again, stub is a type of mock, but it is a completely different concept. But these are the 4 test doubles that I think we absolutely need to understand, and we need to understand the differences between each of these. We cannot call everything a mock. We cannot say that. I don't think if people that are senior developers, or people that are in higher ranking or higher position than you, and if you say if you exactly whenever you are writing unit tests, if you use any of these tools, or if you say that, hey, I want to use dummy, I want to use stub, I want to use fake, or I want to use mock, so I think the managers or basically your boss is going to be super impressed, because you know all these test doubles when writing tests. Okay, but in simple terms, stub is nothing but a working implementation of an API or a service. Okay, so stub is a working implementation of an API or service. So in order to understand stub better, let's look at this get creation date.ts. So this is just a pseudo code. Okay, don't focus too much on the correctness of code here. But in this get creation date, all it does is it takes in a user. If the password is valid and if the email is valid, then we get the date of when that user is created. Okay, so that's all this function does. And in order to unit test this particular function, this get creation date, let's come down to this get creation date.test.ts. So we describe a test suite called get creation date. And because whenever we are only trying to, so you can see that this get creation date function up here, it has a dependency or side effect, and in this case the dependency is this get creation date function itself from user service. Okay, so this user service dot get creation date, this function that we are trying to call from user service, this is the dependency or side effect. Okay, so whenever we are testing for get creation date, do we also need to test this user service dot get creation date? We do not need to test this, because we assume that this user service has already been tested. Okay, if it has not been tested, we go and write unit tests for the user service. Whenever we are writing test for this get creation date over here, we do not test for user service. Okay, we do not test for this function from user service. We only want to test whether this get creation date returns a date or not. Okay, so that is where we stub out the service. Okay, so this is called stubbing out the service. So in order to write unit tests for get creation date, in this test case here, we stub out the service. So if we are using then we can use this mock return value in order to return a date, and then this mock return value that returns a date, we will assign that to user service dot get creation date. Okay, so this is basically we are stubbing out the service. We are not testing user service, whether user service dot get creation date works or not. We just know that it works, and we just want a date from it. That's all we want. Okay, because in this test we are trying to test for get creation date and not the user services get creation date. Okay, so we stub out the user service. Okay, so that's the concept of stub. Okay, that is, we return a date, and then we check if the creation date equals date or not, and then this date is obtained from date dot now. That will provide us a date. So stub, as I said, it's a working implementation of a service or a function where we can predict the value, we can supply pre-canned value. So in order to test for this get creation date, we know that user service dot get creation date works. The user service works great. We do not need to test for that, but we still need to test this function as a whole called get creation date. We need to write unit tests. So in order to unit test this get creation date, but since it has a side effect or the dependency called user service dot get creation date, that's why we stub out the user service, and then we return a pre-canned date using date dot now, and then we just test for this get creation date, and we expect creation date to equal this date here. Okay, so that's the concept about stub. So we talked about dummy, we talk about stub. Let's talk about fake. Okay, so now this is another test double. This is another concept that we really need to understand. And in order to understand fake, let's look at this function here called switch to light theme and switch to dark theme. So this function is called in, let me show you in the app here. So whenever I click on that button, a drawer opens up, and there are two buttons. You can see that I'm currently on dark theme, but if I click on that light theme, it is going to switch to light theme. Okay, so whenever I click on this light theme, it is calling this switch to light theme function, and whenever I click on dark theme, it is calling this switch to dark theme function. Okay, and inside each of this function, you can see that we are using local storage in order to store the theme object in light theme, the theme object in local storage. And also, if you look at switch to dark theme, we are again using local storage in order to set the theme in local storage. Okay, so if I show you over here, let me open up local storage here. So you can see that in local storage there is already a theme object that exists. This is the theme object. Type is dark. Mode is there is some color. Now if I switch to light theme, you'll see that the theme object in local storage is changed too. Okay, and if I click on dark theme, again the theme object is changed. So this is what this switch to light theme and switch to dark theme function does. So now it's time to test, let's say one of these functions. Let's say that we want to test switch to light theme function, because this switch to light theme function again has a dependency, has a side effect. Okay, because we are using local storage here. This is an external service we are using. So whenever we test for switch to light theme, are we going to test this whether local storage dot set item function works or not? We are not, because this local storage the local storage service, the set item API, is already thoroughly tested by somebody else. We just assume that local storage, we know that it works. There is no way that local storage does not work. Okay, we know that it works. We do not write any unit tests, any kinds of test for the local storage. Okay, we are only trying to test whether this function switch to light theme actually switches to light theme or not, or this switch to dark theme function whether it switches to dark theme or not. We are not concerned about whether local storage works or not. We are not concerned about whether that thing is being stored in local storage or not. Okay, and this is where the concept of fake comes in. So fake is just like a stub. Okay, stub is a working implementation of an API, but when we are talking about fake is a dynamic implementation of an API. Okay, so there's a difference between stub and fake. Fake is a dynamic implementation of an API. We use fake whenever our function, whenever our code uses some external services or external API. So okay, so if you look at this switch to light theme, it is using external service, local storage service, and it is using some of the function from the local storage service. Okay, so in order to unit test this both of these functions, what we can do is we can fake the local storage service, and we can also fake some of the functions or the APIs from local storage service. Okay, so in this case, since we are trying to set a theme object to local storage, we can fake this. Okay, but again, when it comes to faking something, do we have to fake the entire local storage service? No, we do not have to fake entire local storage service. We only want to use set item, and maybe, so let's say we want to use get item function from local storage. So that's why we only fake only the functions that we need. So in this case, we will fake set item function from local storage, and maybe we'll also fake get item function from local storage. Okay, so in order to create a fake, this is what we do. We supply a dynamic implementation of set item and get item of local storage. Okay, and then we can define this fake globally, and whenever we use this, whenever we write unit tests, we do not have to change any code. We can still call local storage dot get item, as you see over here, and our the source code and the twist code will still use local storage dot get item, because we are already faking it on top over here, and our test will run when we utilize fake in order to test for switch to light theme and switch to dark theme that utilizes local storage within it. Okay, So that's the concept about fake, and we will talk about this in so much greater detail when we are actually writing tests for the components, for the application, for each of the functions that we will write. We will write a lot of unit tests. It doesn't mean that whenever I said we are focusing, I like to focus more on end-to-end tests, doesn't mean that we are not writing any unit tests. We will still write a lot of them, but we will focus on these concepts more in practical. All these test doubles, we will focus on it when we actually start writing unit tests for some of the functions. Okay, so that's about fake. Now finally let's talk about mock. Okay, and again, this is the umbrella term for all these tests, for all these tools here: dummy, stub, and fake. Everybody calls it a mock. I don't know why, and this is also the fault of some of the testing framework. I think Jest uses each of these concepts really clearly, but if you but in I believe in other testing frameworks, all the testing framework call it a mock or a spy, and all these concepts are lost. I don't know where it is lost, but in some of the testing frameworks, these concepts do not even exist at all, and they only call it a mock. So I don't know why they do that or why they did that. So if you have any better understanding, feel free to let me know down in the comments below, because I could not find why everything is called a mock when it is really not a mock. Okay, so now let's talk about what mock exactly is. Okay, so mock is just like stub. Okay, mock is not like fake. Well, it can also be called just like fake. Mock is just like stub, but mock is an interactive implementation of an API or service. It is not an implementation, but let's say that mock is something. When we are using a mock, we are interacting with the function that we are trying to unit test. Okay, so let's look at this validate password function again. Okay, if you look at this validate password function clearly, there is at first on the top we imported, or I imported here, format password from somewhere. All it does is that it takes in a password from the user, and if the password contains any leading or trailing white space, then it formats the password and removes those white space. Okay, that's all this format password does. And also this, I also have this isEmpty function. This isEmpty function checks whether the password is empty or not. Okay, it trims the password, remove any white space, and it checks whether it contains at least whether it contains some letters, special characters, alphabets or not. Okay, so these are the two functions that is going to get used in validate password function. So if you can see in this validate password function, we provide some regular expression in order to check for that, and then we actually call this format password function. Okay, and provide a password to that format password function, and after that, if password is formatted, we check if the password is empty or not by so this isEmpty function, we are supplying the formatted password. So this it will check whether the password is empty or not. If it is not empty, if everything is working out great, then it returns true, else it returns false. Okay, so in order to unit test this validate password function, we can also use, again, this is mock. Okay, we need to mock something out here. Okay, and what do we need to mock? We need to mock format password function, and we also need to mock isEmpty function. And again, what is mock? Mock is an interactive, not an implementation, but mock is an interactive, let's call it implementation. Mock is an interactive implementation of an API, of a service, of a function. Okay, and interactive means, if you look at let's come and look at a unit test down here. So in order to unit test this validate password function, okay, interactive mock, when I say mock is interactive, it means that whenever we are mocking something, we are trying to test whether a particular function or a service has been executed or not, and we are also concerned about the order of execution whenever we are talking about mock, and also we are concerned about the parameter that the function is called with when we are talking about mock. Okay, so mock is an interactive implementation of an API or service. When we use mock, we are trying to test if the function has been called, how many times the function has been called, if the function has been called with a correct parameter or not, if the function has been called with a correct number of parameter or not, and we are trying to do, by using mock, we are trying to test if the function has been called or not. Okay, so if you look at this validate password function, in order to write a unit test for this, and this is the example where we use mock, so we can use just.spy on in order to spy on this format password function, as you can see on top here. That's the format password function, as I explained earlier. And also we can use a spy in order to mock this password service that contains this isEmpty function. So we use a spy in order to mock this format password and isEmpty function. Okay, and if we come down here, we use mock and we expect the spy format password, this one, to have been called. We expect that the format password function to have been called with password. So in this function, the format password should be called with password, because format password takes in a the password and formats the password. So that's why we use mock and test that format password have been called with password. And we also want to check format password, check using mock. We want to check if the format password have been called exactly one time. We do not want format password to be called more than one time. And same thing with the isEmpty function. We mock that isEmpty function using just spy, and then we expect that the isEmpty function have been called. We expect that the isEmpty function have been called with the actual password, and to check whether the password is empty or not. And we also expect the isEmpty function to have been called exactly one time, because in this original function, the format password is been called exactly one time. The isEmpty function is also being called exactly one time. Okay, so that is the concept of mock. Okay, so I think you now understood the different kinds of tests and all these test doubles. So now the question might be, well, when I'm unit testing something, so let's say that I want to unit test this validate password function, what tool do I need to use? What test double do I need to use? And in order to explain this really clearly, I have a decision tree that I made here. So if you look at this decision tree, the first thing that we do on the top here is this box that says pure function. It has a question mark in there. So whenever we are confused about what to use, whether we should use dummy, stub, fake, or mock, whenever we are confused, whenever we are writing unit tests and we are confused about what tool to use, whether to use mock, dummy, stub, or fake, let's come to this decision tree and ask ourselves a question. Okay, so is the function that we are writing unit test to, is that function a pure function? Or in other words, does that function have any dependency, or does that function have any side effects? Okay, so we ask, is it a pure function? If it is a pure function, we come over here in this yes box. Then we don't need, if it is a pure function, we do not need to worry about any of these tools. Okay, we do not need any of these tools. We can just go and test that pure function. But if it is not a pure function, in other words, if it is an impure function and it has side effects and it has dependency, just like our validate password function has, it has side effects and dependency, or side effects or dependency, and there are two in this case. There is format password and there is also isEmpty. So format password and isEmpty is a side effect of this validate password function. Okay, so we, in this decision tree, we ask ourselves, is that function that we are writing a unit test to, is that function a pure function or impure function? Okay, so in case of validate password, it is an impure function. So we come down to this box here. It is not a pure function, so no, not a pure function. And then we ask ourselves, is it only needed to satisfy the API, or is it only needed to fill the parameter list, just like with this min length and max length as we talked about earlier? Is it only needed to fill the parameter list? Is it only needed to satisfy the API? It doesn't do much in the function. The function can run independently without it too. Okay, and it does not impact our test. We do not need that in test. Then we use dummy. Okay, and if not, we ask ourselves this another question here: do we need any specific value, and can we predict the value? Do we already know the value? Do we know what that function returns? Can we predict the value? Just like with the get creation date. Can we predict the value over here in this get creation date? We can. Well, we cannot predict exact date, but we know that it returns a date. It is going to give us a date. Okay, so we know, we can predict the value that it is going to return a date. So that's where we use a stub. Okay, and when it comes to using fake, we gotta ask ourselves, if it is not this too, we gotta ask ourselves, does it rely on any external services that has dynamic values? And when I showed you this light theme and dark theme example, this is not really dynamic, because all it is doing is setting this static theme object to local storage. But let's say that I have, let's say, a shopping cart, and I keep adding item to the shopping cart, and I want to store that items in local storage, then that would be dynamic. So in that case, we use fake. Okay, does it rely on external services and does it have dynamic values? Then that's where we use fake. Okay, if it is not any of these three, we again ask ourselves, do we need a specific function to execute, or are we concerned about the order of execution, or are we concerned about whether that function has been called with correct number of parameter, or how many times this function has been called? We use mock. Okay, so that was the decision tree. So that is all the things that I wanted to cover in this video, everything that you need to know about tests, or at least when it comes, if you are following that front-end development series, if you are following my front-end development series closely, then you must need to know all these concepts about testing if you want to test your application. I definitely do. So I hope you found this video useful, and have a nice day. See you.